Hello everyone. Today I am going to demonstrate the interfacing and control of a stepper motor using an 8085 microprocessor kit with LCD display. A stepper motor is a special type of motor that converts digital pulses into precise mechanical motion. Unlike ordinary motors that rotate continuously, a stepper motor rotates in fixed angular steps. Typically, one step corresponds to about 1.8 degrees, which means it takes about 200 steps to complete one full revolution. Now coming to the hardware setup, the stepper motor interface module is connected to the 8255 programmable peripheral interface port of the 8085 kit using a 26-pin flat cable. The first pin of the cable is aligned with pin 1 of both connectors to ensure correct communication. The module is supplied with plus 5 volts power and the motor is connected to its power terminals. Next, I will explain the logic of the program. The microprocessor sends hexadecimal values to port A. Each value represents a specific pattern that energizes particular motor windings. For anti-clockwise rotation, the sequence of output code is FA, F6, F5 and F9. These values are sent one after another repeatedly. For clockwise rotation, the same values are sent in reverse order, so direction control is achieved simply by reversing the sequence of output patterns. Speed control is done using a delay routine. After sending each output value, the program waits for a small time before sending the next one. If the delay is large, the motor rotates slowly. If the delay is small, the motor rotates faster. The delay is generated using register pairs and a subroutine loop. By changing the delay constant stored in memory, we can vary the motor speed without modifying the main program logic. Now let us go through the program. First, the accumulator is loaded with control word 80 and sent to port 03. This initializes the 8255 and configures port A as an output port. After initialization, the program loads the first step code into the accumulator and outputs it to port 00. Then it calls the delay routine. The same process is repeated for the remaining step codes. Finally, a jump instruction returns control to the start of the sequence so that the motor keeps rotating continuously. Now, I will execute the program. As you can see, the motor is rotating in anti-clockwise direction because the step sequence is being sent in forward order. Next, I modify the program so that the sequence is reversed. After running again, the motor now rotates in clockwise direction. This shows that direction is controlled purely via software. Now, I will demonstrate speed control. I increase the delay value stored in memory and run the program again. The motor rotates faster. This proves that speed depends on the rate at which pulses are applied to the motor windings. To conclude, in this experiment, we successfully interfaced a stepper motor with an 8085 microprocessor kit. We controlled direction by changing the sequence of output codes and we controlled speed by adjusting the delay between pulses. This demonstrates how digital systems can precisely control mechanical motion. Thank you.